Hello, 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 hello. Am I audible and visible to all of you? Hello, beta. Momin, walaikum salam. Am I audible and visible to all of you? That's great. So I guess yesterday we had studied electric flux and Gauss's law, right? So in today's class we will be discussing more about the Gauss's law. Okay, we will have a quick recap of Gauss's law. Then properties of Gauss's law. Then we will discuss a lot of numericals from it. Then we can just complete these things, and if time permits, we will be having the application part of Gauss's law. Okay. So I guess we need to start now. Okay. Yes, Kamil Khan, walaikum salam. Eid kharch, right? जल्दी जल्दी दिमो तो ईद खर्च पे कुर्बान माज हिसा पे नो क्या कुर्बाना करूं तो इमस तो बह तो कुर्बान माज दिस तो ईद खर्च थोड़ा बहुत ये वो पते है so let's start now. Okay. Okay, so in the previous class we had discussed something. No, we had discussed many things. No, okay, regarding Gauss's law, what Gauss's law is all about, and the validation of Gauss's law. We can also only apply Gauss's law if we have a closed 3D surface. If let us suppose in some cases we need to apply Gauss's law where we don't have the closed surface, so we need to make the closed surface, right? Then we can apply the Gauss's law. Second one is we can use the Gauss's law anywhere which follows the inverse square law. And the okay, and the statement of Gauss's law is very straight, very easy. That is that net flux from any closed 3D surface is equals to the charge enclosed by that 3D surface divided by the epsilon naught. Hmm. जी बेबी ज्यादा है शिव सर को हम करवा okay at the end I will call you, no beta. Then we will discuss, right? In the group we will discuss that askus pe qurban karun. Okay. Okay, look now. So basically we had these three expressions to define or to describe the Gauss's law. First one is the flux net is equals to charge enclosed by epsilon naught. Second one is the net flux is equals to the closed integration of E dot ds. Third one is we can just combine these two and we will get a new parameter here, right? This one, okay. Then we discuss one property that Gauss's law only and only depend the charge enclosed by the Gaussian surface. It doesn't depend on the size of Gaussian surface, the shape of Gaussian surface. It only and only depends on what? The charge enclosed. Enclosed means the charge which is inside the Gaussian surface. Gaussian surface means it is that surface on which we are applying Gauss's law. Done? Okay, then we had some numericals from NEET and from IIT. Let us continue from these particular things. One second. One second. Okay, look now. So we had a numerical, a very good numerical. Okay, we had a very good numerical, and the numerical is like, look here. We had a this particular surface. Okay, and we had a rod, the infinite length rod passing through it. It is infinite. Dotted line is represent infinite. And the density, linear charge density is plus lambda. Okay, look. This will be the center of my this particular circle, and this distance is given to be r by 2, a radius by 2. Okay, what we have to find, we need to find out the net flux. We need to find out the net flux through this surface. So this particular circle represents Gaussian surface. This represents Gaussian surface. Okay, because we are applying Gauss law here now only. Okay, look now how we can get it. Okay, look it up. You can see from this particular figure that to get my phi, that means to get my net flux, it is equals to summation of charge divided by epsilon naught. So epsilon naught is a constant. I don't need to change epsilon naught. So what I have to change, or what I need to put here, is summation of q. Summation of q means the charge which is inside the body. So as you can see now, so this length of a rod is inside the body. So this rod will be giving electric flux. So I need to just find the length of this rod. So what I can do from here now, I will just connect these two ends. I guess this particular side represents hypotenuse. It is a radius, right? It is radius. So how to get this one now? Sir, it is base. So we know that by Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. Hypotenuse is given to be r square. Base we have to find out. Perpendicular is r by 2 square. So I can write r square equals to b square plus r square by 4. So b square is equals to r square minus r square by 4. So my base square came out to be 4r square minus r square whole divided by 4. I guess it came out to be how much? 3r square by 4. So my base will be equals to under root of 3r by 2 only. So this length. So this length now from this to this, it is what? Sir, it is under root of 3r by 2. So what will be the whole length? What will be the whole length? Sir, whole length. My length L. My length will be 2 times of it. No? Look. 1 and 1 more, right? Similar triangle. So can I write it would be 2 times multiplied by under root 3r by 2. 2 to cancel out. My length would be equal to under root 3 times r. So can I write here, sir, my length is under root 3 by r. So what is my lambda? So lambda, we can write it equals to charge divided by length. So what is charge now from this particular equation? Charge equals to linear charge density into length. Length is under root 3 times r. So now charge, no, I can write it. It is sir lambda under root 3 times r. So this is my answer. This is my answer. If you have any doubts no, about it, you can just let me know. These are some important numericals, no? You need to be very great, very good about it. Now look, my answer is this, no? And it is perfect. 0% error. Now if we just add some more points to it, that is, sir, what will be my maximum flux? How to get my maximum flux? Okay, we can add some more points to it now. How to get my maximum flux? Or at what particular position I will get my maximum flux? Okay, for maximum flux, I need maximum charge inside. For maximum flux, na, so listen to me. For maximum flux, I need maximum charge inside the sphere. Yes, sir. So I guess the maximum is this, na. This is my maximum position. Yes, sir. So you can just see from here, na, the length will be equals to 2 times r. So if my rod is this way, so I will get my maximum flux. My maximum flux. Okay. So my maximum flux will be equals to, sir, lambda into 2r whole divided by epsilon naught. This is how we can do it. This is how we can do it. So this is how we can do these things, no? Very easy. Okay, one more. Let us do some more interesting numericals from this particular topic now. Walaikum assalam, beta. Safu. Kasru. Okay. Look now. Suppose we have a numerical in which I will add two topics. I will add two topics, induction and this Gauss's law. How? Look. We have a sphere here. Look. This is my sphere with some radius r. With some radius r. Close to it, we have a point charge with charge plus q. Done? Done now? This is my metallic sphere. Metal sphere. If I make here a imaginary surface, this red dotted line represents my imaginary surface. And it is what? It is Gaussian surface. It is my surface, no? It is my Gaussian surface. So you need to tell me that what flux will be through this Gaussian surface. Is it positive or negative? Is it positive or negative? Okay, sir, how we can get it now? Look, we know that if we have any charged particle, closer to any neutral substance, neutral sphere, neutral material or metal, na, it will just pull the opposite charges towards its end. That means if it is positive, so the negative charge of this sphere will be towards this, right? And it will push positive charges away from its surface. If I have a negative charge inside now, I guess my my flux will be negative, right? So I can write, sir, my charge that is inside, it will be negative. So I can write my flux will be negative. Easy or tough? Easy or very easy? Okay. Okay, look now. Let us do some more amazing numericals from it. Look now. Look now. Now we have a bowl like structure. It's my bowl like structure. The hemispherical bowl, okay? And my charged particle is at the surface. This is my charged particle. Okay, which charge Q. Which charge Q. Okay. Find flux. You need to find flux. First of all, sir, we know one thing that we can apply Gauss's law only if there is a closed surface and my charged particle should be inside it. So if we are seeing this particular figure, my charged particle is not inside, it is at the surface. Okay, if this is my surface, it is at the particular surface, right? It is not inside it. So if my charged particle is not inside it, so how we can proceed then? We have a trick for it. What is my trick? Sir, by symmetrical, we can have multiple things on it now. But for our easiness, for our easy calculation part, I can put here what? I can put here one more hemisphere. Okay. Now you can see now, you can see, sir, it is a single sphere. It is what a single sphere. So look, it is my single sphere. Now what is my flux? Sir, if I can write, the flux through the whole body will be Q by epsilon naught. Okay. But I don't need the whole body. Now I need only the wide portion. Okay. I guess the wide portion is it is half of full. I guess my wide portion is half of the full. Okay. So the flux through it. So my flux through the wide portion will be Q by 2 epsilon naught. Easy? It will be Q by 2 epsilon naught. Done? One second. Okay. So this is how we can do it now. Let us do one more, the most important. What happened? One second. Okay. The most important cases of flux, that is cube. What we have now? Cube. Okay. Look now. So I am making a cube. I guess cube is a 3D structure, a closed 3D structure. Okay. With 6 sides. Okay. And my charged particle is inside. No? It's my charged particle inside. So what is flux? What will be flux through the cube? Sir, my flux, that is phi, it will be equals to summation of charge. Sir, inside the charge is Q only. Now, so I can write Q whole divided by epsilon naught. Correct answer. Okay. Correct answer. But if I just ask you, how many faces does this cube have? Sir, 6 faces. 6 faces. No? So what will be the flux through each face? Flux through each face. Sir, my total flux divided by 6. So can I write it equals to, sir, Q divided by 6 is epsilon naught. Can I write like this? Yes, sir. Okay. So my total flux divided by the number of phases, I will get my flux through each phase. Okay. So let us suppose the flux through this one shaded portion is how much? This shaded portion, it is Q by 6 epsilon naught. Done? Okay. One more. Look, if we have a cube here, if we have a cube here, this is my cube, and my charged particle is not inside, it is at this surface, okay, this is my charged particle, as you can see now, my charged particle is not inside, it is at the surface only now. So if we need to apply Gauss's law, so we have to make the charged particle inside it. How we can do it? I can apply the cylinder also up the upper side. I can use the hemispherical things, right? But by symmetrical, we need to only apply the cube only. So I can put one more cube here, right? I will apply one more cube here. Look, one more cube. Okay, now what will be the flux through these two? Sir, my flux through whole Gaussian surface will be equals to the charge by epsilon naught. But I don't need the whole one. Now I need the lower one. So what will be the through only this one? Sir, my flux through this one would be q by 2 epsilon naught. Easy? Easy or super easy? Easy or super easy? Super easy? Okay. Okay, change these perspective now. Okay. Look now, one more numerical, one famous numerical, famous profile, that is, if I have now here this cube, okay, and my charged particle is at this corner. It is at this corner q. Okay, find flux. How I will get this flux? Okay, so sir, I need to make this point inside the surface. Inside the, how I can get it? Look, I have to make one more cube this side. One more cube. One more cube, no? Okay, but still it is not inside. So I have to make one more cube here. Look, one more cube here. Still not inside. One more cube here. Still not inside. So I need to make one more cube here. Look, still not inside. One more cube. Still not inside. I will make one more cube. Look, one more cube here. Still not inside. I will make a last cube. This one. No? Look. Now you can see my charged particle is inside now. Okay. By doing all these things now, I can conclude now my charged particle is inside. But look, all these my cubes, one cube, two cube, three, behind the between it is four. Now this is fifth, sixth, seventh, eighth. So we have 8 cubes. We have, so what will be flux through through the whole Gaussian surface? Sir, it is what? It is q by epsilon naught. And what will be the flux through one cube? Sir, total net divided by the number of cubes. Sir, it is 8. So I can write it is q by 8 epsilon naught. Q by 8 epsilon naught. Easy? Easy or very easy? Very easy, no? Hmm? It's very easy. Okay, let us level up the numericals, right? Let us do a great numerical from this particular case. That is, now look, this is my cube. This is my cube. This is my cube. Okay, look now. And my charged particle is at this corner. Okay, so what will be flux? What will be the flux through this cube? Sir, we got it now. Now it is q by 8 epsilon naught. So the flux through the whole cube is q by 8 by epsilon naught. So what will be the flux through each side now? What will be flux through each side? How many sides we have here? Sir, I have 6 sides. So if I am giving you the question now, what is flux through each face? Sir, you can write flux divided by 6 times. You can write it would be q divided by 6 into 8 into epsilon naught. Clear? You can write this one, no? Huh? You can write like this. So my answer would be, sir, Q by 6 8s are, it is 48 epsilon naught, but it is wrong. Do you know why? Look, if we talk about this, if we talk about this side, look, my flux will be in this way. Look, this is my flux. It's my flux. Okay. And my electric field will be in this way. I guess angle is 90 degree. So flux will be 0. So from this particular line, it is first phase. So flux is 0. Let us talk about the upper phase. Upper one, no? Same. You can see, sir, my flux, my lines would be like this, and my area is in this way. So angle is 90 degree. So my flux is 0. Flux is 0. So from flux second, it is 0. Now the previous, the back one, this one. So flux from this one is also 0. So it has 6 sides. This cube has 6 sides. So 3 sides, my flux is 0. My flux is 0. Okay. So can I write now flux through each phase, is it equals to flux, whole flux, that is Q divided by 8 epsilon naught into 1 divided by 3 epsilon, 1 divided by 3 only. You know why? Why? Because my flux is only divided into 3 parts. Because 6 part in through 3 parts, flux is 0. So whole flux is going through 3 parts only, right? So flux through my phases. Okay, this is one phase or A phase. The bottom one is B phase and 3 phase. Only I will just make it now. This phase, this one, and this one. Okay, so flux will be from these 3 sides only, right? So my flux will be Q divided by 24 epsilon naught. Okay. Easy बेटा. कैमल खाना क्या मतलब सोच रहा हूँ? Easy? Super easy, right? This is how you can do it, no? Okay. Okay, look now. So yes, most students are doing this mistake, right? This cube divided by 48 epsilon naught, but it is incorrect. It is now incorrect. Look now. So step by step, we are increasing the hardness of our numericals. Okay. Look now, one more numerical. Look now. This is my Gaussian surface. That is my cube. This is my cube. So we have 3 charged particles. One is inside. This is Q1. One is here. Q2. One particle, let's suppose, is here. Is it Q3? Okay. And I'm just, this is my shaded one. Find flux through this shaded portion. Okay. So we have 3 charges. If we talk about Q1 charge, it is at the center. So my flux due to first one would be, sir, Q1 divided by epsilon naught into 1 by 6. Okay. Now Q2 charge is at the corner. This one, it is at the corner. Okay, so my flux 2 would be equals to, sir, Q2 divided by epsilon naught, 8 epsilon naught into 1 by 3. If we talk about Q3, sir, Q3 will give my flux Q3, that will be 0. Why? Because we discuss it now, 90 degree. So what will be my net flux? Sir, net flux will be equals to Q1 divided by 6 times epsilon naught plus Q2 divided by 24 epsilon naught. It's my total flux. This one is my total flux. Okay. Okay. So that's why we are just going very slow right now, right? Because to get a very good understanding of these topics, I am going very slow. Okay, one more numerical from cone. If we have a cone here, cone. This is my cone. It's my cone. Okay, and my electric field is in this way. It's my electric field. It's my electric field. And height of this cone is given to be h. What is my incoming flux? I know that net flux is 0. I know that net flux is 0, but I only need to find the incoming flux. We know that if we have incoming flux, it will be negative. Okay. Now, flux is equal to, how to write flux? Sir, it is E dot A. So what is E? Sir, E is given to be E. What is area? How to find the area of it? I told you, no, that it is area will be in this way. Look, I have to make a maximum area. So at the center, it will have its maximum area. Yes, sir. So this length would be how much? If R is radius of it, so this would be 2R and height is H. It will be a rectangle. So how to write the area of it? Right? So 1 by 2 base is 2R into height is H. 2 to cancel out. So my flux would be minus ERH. If you need to find outgoing flux, that would be plus times ERH. So what is net flux? The net flux will be 0. We know it. We know it, no? नहीं बेटा नींद नहीं आती है. Because we had to cover the syllabus now before anyone else, right? Because then we need to start 11th also for our NEET students, for our J students. So firstly, we need to complete each and everything, quality thing, right? You're gonna find many materials, no? But here I'm just doing each and every numerical for your goodness. Now, after attending my class, no, just do the DPPs from your own institute, no? Then you can you will just tell me the quantity and the quality of my numerical that I'm just giving to you. Chali. Okay, now next one. We have very good numerical, and that is if we have this coordinate system. This is my coordinate system, and you will find one numerical from your NCERT also. Okay, the solved numerical from NCERT also. The alpha a power 1 by 2 one. Okay. My x-axis is my y-axis, and this one my z-axis. And I have a cube here. Look here, I have a cube. This is my cube. Here I have my cube. Okay, this is my cube. We are seeing it 2D now, but it is a cube. Okay, and my electric field is given. My electric field is given. Sir, it is equals to 2 under root of x I cap. Length of this cube is given to be A. Find flux. So here you can see from this particular equation that electric field is not uniform. It depends. Thank you, beta. Okay. I know each and everything in this coaching industry, right? Up to date, I know each and everything. So look here, my electric field is not constant. It is varying based on the position. Okay. So I can write here, sir, look, it is varying. Okay. So depends on position. It depends on position. Position means X. So for different X, we will be having what? Different electric field. And my electric field is only in X direction. I mean it is only in X direction. It is only in X direction. So my electric field will be in this way, in X direction, in this way. Okay, now we know that only these two phases will be in electric flux. Why? Because here you will find cos, you will find 90 angle, here 90, back 90, front 90. So only these two sides will be involved in my flux. Okay, so if you want to calculate flux, so this side will be giving phi1, this side is phi2. What is phi1? Sir, phi1 is equals to electric field minus into area is A. Phi1 minus E. What is E? Sir, E is equals to 2 under root of X. What is X? I guess this is my origin, 0, 0. So I will place X as a 0 into area. Area is what? It is A square. So my incoming flux will be 0. So let's talk about this one. Look, my electric field is in this way, that is, it is outgoing. So my outgoing flux is always positive. I can write positive E. What is E? 2 under root of X. What is X? X is the distance. Now it is A. So it is A. Okay. Into area. Area is A square. Okay. So I can write phi2 equals to 2 A power 1 by 2 multiplied by A power 2. Base is same. So I will add my powers. Base is same. So I will add my powers. Done now? So I can write 2 A power 5 by 2. This is my answer. This is my answer. Okay, if somebody will ask you that, yeah, phi, we got the net phi. So if somebody will ask you that you got now the net phi is 2a 5 by 2. You got it. Now, how to find the charge? How to find the charge? We know that, sir, phi net is equals to summation of charge divided by epsilon naught. If I need to find the charge, charge will be equals to phi net into epsilon naught. So phi net is how much? It is 2a power 5 by 2. Then epsilon naught is equals to 8.8 10 to the power minus 12. This is my answer. Easy? Easy or super easy? Easy or super easy? Huh? Okay. Let's do some numericals from NCRT and from SCB. Okay. So first numerical we will be doing from NCRT. We had discussed this numerical back in our prior sessions, right? Look now. If I have a square, this is my square. This is my square with side A. And above this square, here 5 centimeter from the center of it, I have charge particle Q. What will be flux through this particular region? What will be flux through this region? Flux. What will be flux through this region? Basically, it is a 2D figure, na? So we cannot apply Gauss Law here. So we need to make it 3D. So can I make it like this? Can I make it like this now? Yes, sir. Now it is 3D. So what is flux through the hole? Sir, flux is equals to charge divided by epsilon naught. What is flux through this only? Sir, flux will be equals to Q divided by 6 epsilon naught. Done? You see? Okay. From NCRT, let's do some HCV numericals. Do some HCV numericals. Okay. If we have a structure, the cylinder like this, and on the top we have a charged particle here with Q. What will be the flux? We know that, sir. I will make a one more a hypothetical surface. So my flux will be equals to Q divided by epsilon naught. It is whole. From this only, my flux will be equals to Q divided by 2 epsilon naught. This numerical is from HCV. And this one also, na. This one also the hemispherical one. This is also from HCV. S.C. Verma book, right? Again, it's a very famous book. Okay, so we had discussed these things now. So let us do a very good numerical. Very good numerical. A very tough one also, okay? Tough one also. How we can do it? Look, I will write the whole language of numerical. A long wire of linear charge density. Long wire of linear charge density lambda passes through a cube of side L, such a manner that flux through it is maximum. Through it is maximum. Now the position of the wire is changed in such a way that flux is minimum. The ratio of maximum flux to minimum flux is. So we need to find out the ratio of maximum to minimum flux. So first of all, we have to make a diagram. Okay. So if this is my cube, so you need to think about the longest side and the shortest side. Look, for maximum flux, we need a longest side. For a minimum flux, we need a minimum side. Okay. So for minimum, we can have a rod like this. Nothing more special. It is simply like this. If length is L. So by doing this thing, we will get a minimum flux. Okay. Summation of charge divided by epsilon naught. Charge is not given, lambda is given. So we know that charge is equal to lambda into L divided by epsilon naught. First equation. If we want maximum flux, so maximum flux will be if we have from this particular corner to this one. This. Okay. Look, if this is L, this is L. So this side will be root 2L. Root 2L, this is L. So this side will be root 3L. Maximum pore side. This is a maximum length of the rod inside a cube. It is under root 3L. Under root 3L. So what will be the maximum flux? Sir, my maximum flux will be equal to summation of charge divided by epsilon naught. Is it under root 3 times L lambda divided by epsilon naught? Yes, sir. Done. So what is my maximum flux to minimum flux? So maximum flux is equals to under root 3 L lambda divided by epsilon naught. Minima is lambda L divided by epsilon naught. Cancel out, lambda lambda cancel out, L cancel out. I guess my answer is under root 3 is to 1. This is my answer. This one is my answer. Clear? This one is my answer. Easy or tough? Is this easy or tough? Huh? Easy or tough? Please let me know. Madhu Mathur, where beta? Previous question error. Which one? Which one? Second previous. This one? NCRT one or HCV or previous? This one? This one? I'm not getting a response from your end, no? Yes, area vector is per. Yes, area vector. Look now. This is my cube, okay? I will just make it in 3D now. This is my cube. Look here. So my electric field is going in this way. This is my electric field now. So if we talk about this face, so my area vector will be out. If let's suppose this is my face, so my area vector will be how much? It will be out, no? So my electric field lines are in this way and my area vector is out. So my flux is 0. So from this particular phase, my flux is 0. Now let us talk about the upper one. Look, this is my electric field and this will be my area vector. Again 90 degree. So from upper phase, flux is 0. In the same way, if we talk about the back one, this one, no? Back one, okay? If we talk about the back one, so flux is 0. Flux is 0. Done? Now, my electric field, it is not a uniform or it is depending on the position. Look, X, na? It is depending on the position. That means, look here. So this position, if this position is origin, so 0, 0, this position, it is length now. So my X is equals to A. So here at this particular position, my electric field is 0. This position, my electric field is equals to 2 under root of A. Okay, done? Doubt clear? Done now? Madhu Mathu beta. Done? Okay, great. So we are done with these things. Now let us discuss application part now. Okay, we have half an hour time now. Application part. We are discussing application part. Application. So first application, that is, if we have conducting sphere or if we have spherical shell, both are same, conducting sphere or spherical shell. So we have to apply Gauss's law to get our electric field. We have to apply Gauss's law to get our electric field. Done? Look how we can do it. Look now. So conducting sphere, I guess if you have watched my first lecture of electrostatic, there we defined a last property of charges, charge distribution. So we discussed it broadly two types, conducting and non-conducting. Then the line that I just wrote there, that was the distribution of charge indicates the behavior of electric field. If the distribution of charge is same, so my electric field behavior is same. If you are not watching, watch the first lecture, right? The last 20 minutes. Here, so what we have is, sir, we have here a conducting sphere. This is my conducting sphere. Okay, and it contains plus Q charge. Plus Q charge, that means the charge is on the surface, like it is my charge. It is conducting. So on conducting, my charge particle is always on the surface. It is always on the surface. So if the radius of this conducting is r, so we are just taking any point here, r distance apart, it is point P. So look, this is point number first. It is at the surface, point number second. Point number third is inside, and point number 4 is at the center. So what will be the electric field at point number first? What will be the electric field at point number first? If you want to look, if you want to derive it, how you will derive it? If you want to find electric field at any point, make a Gaussian surface. Look, this will be a Gaussian surface. Okay, and Gaussian surface, my electric field will be E dot ds equals to summation of charge q divided by epsilon naught. E is constant, charge is same, so I can take E outside. Integration of ds equals to summation of charge q is charge inside divided by epsilon naught. Clear? E, what is the area of the sphere? Sir, 4 pi r square equals to q divided by epsilon naught. So E will be equals to 1 over 4 pi epsilon naught into r square into q. So can I write it as q, kq divided by r square? If you have remembered, this is the electric field due to point charge also. Electric field due to point charge. Due to point charge. Okay, so this sphere will behave like a point charge. This sphere will behave like a point charge. So electric field at A, first point, it is equals to how much? K q by r square. Electric field at 2, this point, it will be same, K q by, but capital R square. Electric field at 3, look, we know that inside any conducting sphere, electric field is 0. Look, why? Because there is no charge inside, If inside charge is 0, so my electric field will be 0. Okay. Similarly, with case number 4, at 4, no charge, no electric field. So now we have pointers outside the sphere, on the surface, inside, and at the center. Now let us draw a graph. Drag graph or a graph. This is my R. This one is my electric field E. Look, when we are going from center towards my radius R, electric field is 0. Now from center to back, then it it behaves inversely. It is 1 divided by R square. Okay. So my electric field will be maximum at the surface, then it will decrease. Hyperbola. Easy, no? Easy or tough? Is it easy or tough? Easy or very easy? Huh? Easy or super easy? Super easy, no? Okay. The first application was conducting sphere or spherical shell. Let us talk about second point. Talk about second point. And second point is what? Non-conducting. We have non-conducting. The charge distribution is different for non-conducting. That means the electric behavior will be different. So in non-conducting, we have first part. First part is if the charge is uniformly distributed. If it is uniformly distributed, okay, uniformly distributed. That simply indicates if we have a sphere like this. If we have a sphere like this, okay, and inside the sphere we have what? Charges, but it is uniformly distributed. It is uniformly distributed. Then we know that we need to take 3 points now: outside, at the center, or inside. If I am taking a point here 1, and if the distance is r, look, if the distance is small r, okay, so electric field at this particular point will be same. What, sir? It will be k q divided by r square. I don't need to derive it now. Why? Because we have derived it upwards, right? Here, same, you can derive it. Okay, now on the surface, so what I can write? So this is my outside. So surface means this 2 point. So electric field at the second point, I guess it will be equals to kq divided by r square. Look, now inside charges are present. Now inside my charges are present. I can't write here it is 0, right? So how to get it now? How to deal it now? Look better. How to get it clear? I need to zoom it. So that you will get a better understanding of it. Okay. This is my surface. You can see it clearly, no? It's my surface. Okay. So we have to take a point inside. I will take our point inside. Look. This is my point inside. It is R. Let us put it is R. So what I can do now, I will make a Gaussian surface. This is my Gaussian surface. Okay. This represents what? My Gaussian surface. We know that density is a property of the material, or density is the property of the charged particle. So the density will be same. I know that density is same. So how to write for this particular line? I will write integration of E dot ds. It is equals to summation of charge divided by epsilon naught. What is E? Sir, I will take E outside because it is constant. Same. What is ds? ds is the area. What is the area of this Gaussian surface? 4 pi r square? Yes, sir. It will be 4 pi r square divided by epsilon naught. But what is delta? What is charge inside? What is charge inside? How to get my charge inside? Look better. For charge, I will write here. Look, I will write here. Look, the charge on the whole sphere is Q, and it is in the volume of 4 by 3 pi r cube. That means in whole this structure, my charge is Q. So in one unit, in my 1 unit, my charge will be equals to Q divided by 4 by 3 pi r cube. Done. But if my volume is 4 by 3 pi r small r cube, so my charge will be equals to Q divided by 4 by 3 pi r cube multiplied by 4 by 3 pi small r cube. 4 cancel out, 3 cancel out, pi cancel out. So my charge will be equals to Q r cube divided by r cube. This is charge which is inside now. So can I write it how much? It will be equals to Q r cube. Okay. It will be, sir, it is Q r cube divided by capital R cube. So my E is equals to 1 over 4 pi epsilon naught. That what we have into Q into R cube whole into R cube, then we have R square. R square, it cancel out, so my it becomes Q divided by 4 pi epsilon naught into R divided by R cube, or I can write electric field inside equals to KQR divided by R cube. This is electric field inside. This is electric field inside. I know it is a little bit tricky now, but you need to remember it now. Okay, if this is electric field inside, but it is in the terms of radius and charge. So what if we change the whole scenario into the density? How to get it now? Look better. What is density? It is a rho is equals to charge. Is it what? Charge divided by volume. Volume. Density of hole is rho. Charge hole is Q. Volume will be 4 by 3 pi capital R cube. So therefore, my charge will be equals to rho. 1 second. My charge will be equals to rho multiplied by 4 by 3 pi r cube. This is my charge. What happened to it? 1 second, beta. So Q equals to rho, it is 4 by 3 pi r cube. This is my charge. Now place the value here. So I will get my E. So E is equals to KQ. What is Q? Q is rho 4 by 3 pi r cube into r whole divided by, I will just do one thing now. I will just one thing. Look now. It is pi r cube. It is 4 by 3. It is 4 by 3. It is rho. Then K. So instead of K, I will write 4 pi epsilon naught. Then R cube. R cube cancel out. 4 cancel out. Pi cancel out. So my electric field, I will take it outside now. It will be not visible. So my electric field is equals to rho R divided by epsilon naught. So 3 epsilon naught. Rho R divided by 3 epsilon naught. Okay. So I will now zoom out the whole thing. 1 second, 1 second. It will take some seconds to get it on this previous zone. And this one is not easy, na. I will not tell, na. I will not ask you that is it easy or tough. One second. Okay, this is good now. Okay, so I will write here now. So electric field outside. I will write here electric field outside. It is equals to KQ by R square. Electric field at the surface. It is equals to KQ divided by capital R square. Electric field inside. It is equals to KQR whole divided by R cube. In terms of density, it is equals to, I guess we got it now, beta. It is R divided by 3 epsilon naught. This is my value. Okay. I will not tell you that is it easy, ask you is it easy or super easy, right? So, but this thing you need to remember now. This one you need to remember. Sigma R, sorry, this rho R divided by 3 epsilon naught. Huh? Easy, beta? I know it, it is not easy. One second. It is easy or super easy, this one? We will increase the level, now. We will increase the level. Don't worry about it. This was a uniform distribution. Now we will do a non-uniform one. Okay? We will do a non-uniform one also. Easy? Okay, so let us do one more. Today, I think if I will take some 10 minutes more, now, so we will complete whole this Gauss's law concept. Okay? Be with me. Be with me. Look now. Let us we have a question. If we have a non-uniform charge distribution, if we have a non-uniform charge distribution, suppose, and this numerical was asked in JEE means, also in AIMS. Okay, and it gives us that we have a solid ball. We have a solid ball, and density is given to be rho naught 1 minus r by r, and we need to apply it if r is less than or equals to r and more or equals to 0. That means my density varies inside the ball. We have a solid ball. Solid ball. Inside the solid ball, my density differs, right? Density is not same. It is rho naught 1 minus r by r, but only inside. it is only inside. Now it doesn't, it changes. Okay, look, so let's start this numerical. So, we have, this is my sphere. This is my sphere. And my charge particle is non-uniform. It is in this way, let us suppose, okay? Non-uniform, no? The question stated is it is non-uniform, okay? I will zoom it. You can see from the figure also, it is non-uniform. So, we know that outside my electric field will be same, kq by r square. We know it now. Q is not given. One more thing is Q is not given. My charge is not given. How to do this numerical? How to do it? First and foremost important thing that is given to us now, that is my density. That is my density. Okay, beta? 1 second. Okay. So my density is given. So I will just manipulate the numerical by density only. So I get density is given to me. It is rho naught 1 minus r by r. Is it? Yes, sir. And what is density? What is density? Sir, density is charge by volume. Charge by volume. Okay. And density is how much? It is rho naught 1 minus r by r. What is charge? Sir, we don't know. And it is changing. Now, I will take a small element here. R distance is small element and the width of this particular portion is dr. Okay. So what is volume of this one? What is volume? Sir, volume is area into length. What is area? 4 pi r square and length is dr. So charge will be dq. And what is volume? It will be 4 pi r square into dr. Okay. So I need to find dq now. So dq is equals to rho naught 1 minus r by r 4 pi r square into dr. Now integrate it. Center is 0 and radius is r. So I will get q is equal to rho naught is constant, 4 pi is constant. Integrate from 0 to r. So I will multiply it now. So it will become r square minus r cube by r with respect to dr. With respect to dr. So my charge will be equals to rho naught 4 pi. Integration of r square will be r cube by 3 minus 1 by r. Integration of r cube will be r to power 4 by 4. Upper limit and lower limit. Rho naught 4 pi. I will place the limit. It will be r cube by 3 minus 1 by r. It will be r to power 4 by 4. 1 r cancel out. So my charge will be equals to nu naught 4, sorry, rho naught 4 pi. Then I will take r, it is r cube by 3 minus r cube by 4. So I will let q is equals to rho naught 4 pi r cube. I will take common. Then I have 1 minus 3 minus 1 by 4. So I can write q is equals to rho naught 4 pi r cube. 4 minus 3 divided by 4 is 12. 4 ones are 4, 4 is 12. Okay. So I can write it. Q came out to be rho naught pi r cube. It would be 1 minus 1 by 3. 1 by 3. Okay. So my Q came out to be how much? Sir, pi nu naught by 3. Pi nu naught by 3 into r cube. So this is my charge, but I have to find out what? Electric field. So I guess I can write E dot ds equals to summation of charge by epsilon naught. What is E? Sir, E is constant. It is outside and the area is 4 pi r square. Then summation of q, it would be pi nu naught by 3 r cube, nu naught by epsilon naught. Okay. So I can write E came out to be, it would be how much? Look, pi cancel out. 4 is a 12. So I can write rho naught r cube divided by 12 epsilon naught r square. This is my answer. Easy or tough? Huh? Is this one easy or tough? Beta? Easy or super easy? Easy or super easy? Huh? I'm not getting a response from your end. No? My network is good. Okay. Done. So I guess we had done application 1, 2, application number 3rd. Application number 3rd. It is uniformly charged non-conducting sheets. Uniformly charged non-conducting sheets. That means if we have a sheet like this, it's my sheet now. It's my sheet. Okay. And the sheet will be infinite. Okay. Infinite sheet. And I need to find electric field here. So what I can do now, I will just make a cylinder like this. By symmetry, I will just extend it like this. Okay, this is positive plus sigma positive. So my electric field will go in this way. It's my electric field. Also, my electric field will be in this way. Area of cross section is suppose A. So area of cross section will be the A. So the curved surface area, this one would be, let's suppose it is A2. Okay, look here. So flux, what is phi net? So phi net will be equals to phi1 plus phi2 plus phi3. Phi1 is this one. Electric field and area is both same way. So it will be how much? Same. It will be same. So again, it is EA cos 0 degree. Phi2, this one, this is 2. Second part, it is same EA cos 0 degree. Third one will be EA cos 90 degree. This is third one, okay? First one. I can write 2 times EA. So my phi net will be 2 times EA. Done? Easy, no? Easy? Okay. And we know that phi is equals to summation of charge divided by epsilon naught equals to 2 times E times A. What is sigma? What is sigma? Sigma is equals to charge divided by area. So Q equals to sigma into A. So I can write, sir, sigma into A divided by epsilon naught equals to 2 times EA. AA cancel out. So therefore, my electric field is equals to sigma divided by 2 epsilon naught. This is my answer. And you can see it is independent on this length. That means if you are calculating electric field here or here or here, everywhere electric field value will be sigma by 2 epsilon naught. 2 divided by epsilon naught. Easy or super easy? Is it easy or super easy? Huh? Super easy? Okay. If you need to make a graph of it, now look. It is graph will looks like this. R and electric field. It is graph will be constant. Okay, sigma by 2 epsilon naught. It is graph. Done, no? Okay, let us do some numericals, right? Let us do some numericals. Okay, yeah, we'll do some numericals. Okay, so if we have two plates with density sigma, one more density 2 sigma. Distance between them is r. This is midpoint. Find electric field. Look, due to this sigma, both are positive now. So this sigma will be pushing it in this way, E1. This will push it in this way, E2. What is E1? Huh? Sigma by sigma. That is 2 sigma by, no, it is sigma only now. Yes, sigma. Sigma by 2 epsilon naught. This one, it will be sigma 2 sigma by 2 epsilon naught. 2 cancel out. So E2 came out to be sigma by epsilon. And E1 came out to be sigma by 2 epsilon naught. Both are opposite to each other. Both are opposite to each other. So therefore, my E net will be equals to, it is E2 minus E1. Why? Because E2 is more and E1 is less. So what is E2? It would be sigma by epsilon naught minus sigma by 2 epsilon naught. My answer is sigma divided by 2 epsilon naught. It was asked in AIMS. Easy enough? It was asked in AIMS. Done? Let us do a numerical from IIT. IIT numerical. Look, we have plates plus sigma charge density. One more plate minus 2 sigma charge density. One more plate minus sigma charge density. Okay. Here, what will be my electric field? Here, what will be my electric field? First of all, I will take this minus sigma. Electric field will be towards it. E will be sigma by 2 epsilon naught. Minus is towards, so it will be in this way. It will be E equals to 2 sigma divided by 2 epsilon naught. Positive will be away, so it will be away in this way. It will be sigma by 2 epsilon naught. So what is phi net? Huh? So we are not phi now. We are controlling E, right? It will be E net now. 1 second. What is E net? I guess sigma by 2 epsilon naught plus 2 sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Cancel out. 1, 2, it will be sigma by epsilon naught plus sigma by epsilon naught. I guess my answer is 2 sigma by epsilon naught. If we want, it is a vector form also. It would be 2 sigma by epsilon naught, and downward it is, that is minus k cap. Easy or super easy? Super easy. And these numericals were asked in IIT, right? Okay, one more numerical. So if we have two layers, look, one more numerical. One layer, look, sheets, no? Sheets plus sigma charge density. Some distance apart, we have one more. Same charge density. We have 1 point, 2 point, 3 point. Find electric field at these points. Look, due to this one, electric field will be outside. And it will be how much? Sigma by 2 epsilon naught. Due to this one, it will be how much? Outside. Sigma by 2 epsilon naught. So if you need to find net, so net will be how much? Sir, sigma by, it will be sigma by epsilon naught only. Similarly here, due to this one, it will be outside, sigma by 2 epsilon naught. Due to this one, it will be outside, sigma by 2 epsilon naught. So just plus these two, so my electric field will be equal to sigma by epsilon naught. So at this particular point, it is electric field will be outwards, E, that is sigma by 2 epsilon naught. Due to this one, it will be outward, that is sigma by 2 epsilon naught. Both are equal and opposite, so cancel out, so E will be 0. E will be 0. E is 0 between these two, okay? Done? So I guess we had done 4 application. Application number 4. 4 is if we have uniformly charged conducting plate. It is not sheet, it is a plate. Plate means thickness, sheet with thickness. Okay, this is sheet with thickness. Okay, look, if it is a plate now and conducting, the whole charge will be on the outer surface only. Whole charge will be on the outer surface. It is 3D. Let us make it in 2D now. It is now 2D. Look, 2D here, very close to each other. Plus sigma, plus sigma. Okay, so here, what will be electric field here? What will be electric field here? What will be electric field? Done. So here we got now sigma by 2 sigma by epsilon naught. It is sigma by epsilon naught. Here electric field is 0. Here electric field is sigma by epsilon naught. I guess we discussed these things, no? Clear? Okay. So if let us suppose we have 2 with plus sigma, then with minus sigma. So what electric field at 1 point, 2 point, 3 point. Due to this one, my electric field will be outward, sigma by 2 epsilon naught. Due to minus, it will be in this way, sigma by 2 epsilon naught. Both cancel each other, so it will be 0. Here, due to this one, electric field will be sigma by 2 epsilon naught. Due to this one, it will be how much? Sigma by 2 epsilon naught. Both cancel each other, so electric field is 0. Here, due to this one, electric field will be in this way, sigma by 2 epsilon naught. Due to minus, in this way, sigma by 2 epsilon naught. So what will be my electric field in net? Sigma by epsilon naught. Easy? Easy or super easy? Easy or super easy? Super easy. So I will take 10 more minutes, then we will just complete the session. Okay, 10 more minutes. 1 second. So how many things we have discussed so far? So first of all, conducting sphere shell, the graph was like this. Okay, we have not make any graph for this one. Now look, let me make a graph for this one. Okay, look, RE. If you are seeing inside, now inside it is proportional to the R inside, in this way, proportional to the R. Now at surface it is maximum, then it will go in this way. Okay, this was, I was missing it one. So this one we had done. Then we had done this one with graph also. Yes, some numericals. This one is same, the previous one. Okay, so what to do now? 1 second. Let us do 1, 2 numerical, then we can just complete. No, look, numerical is like, and it was asked in JEE. Okay, we have uniformly charged sphere, and electric field inside is equals to A into R. Find charge. Fine. Look, it is not mentioned any specific material or specific portion, no? Conducting, non-conducting. If nothing is given now, so you have to consider solid non-conducting. Solid non-conducting. Okay. So we know that for E inside, which is given to us, it is A into R. But what is for inside? We know that the inside is K Q R whole divided by R cube equals to A into R. R cancel out. So my K will be equals to A R cube divided by K cube. Easy? Okay, one more numerical. Last numerical of today's class. Last numerical. Also asked in JEE. It is if we have uniformly charged sphere. If we have uniformly charged sphere. and E inside is given as that is 2AR. 2AR. Find charge density, find rho. Look, it is non-conducting now. So what is a non-conducting electric field? Sir, KQR by RQ. But we have to find out density. So we need to place the density formula here. No? It is rho R divided by 3 epsilon naught equals to 2AR. R cancel out. So rho will be equals to 2A 3 epsilon naught divided by no, this one only, right? So I can write 3 to the 6. It will be 6A epsilon naught. This one is my answer. This one is my answer. Done? Done, no? Okay, one last application part. Application number, I guess we have done application up to 4. Fifth one. Look, we have a line charge, infinite line charge. Plus lambda, infinite. Okay. So just find electric field here. What to do? Just make a cylinder. With a radius r. It is infinite, no? It is infinite. Yes, sir. Look, electric field will be outwards. And area will be outwards. So theta is 0 degree. So we had done this one, no? So electric field is equals to 2k lambda by r. Is it 2k lambda by r? We can prove it also now. Look better. Look, from this particular portion, no flux. From this portion, no flux. So my flux will be through this one only, right? So what to write? Sir, flux E dot ds equals to q divided by epsilon naught, summation of q. E is E. What is ds? It would be 2 pi rl, curved surface of your cylinder. Charge. What is charge? So it is not given to us, no? It is not given to us. This charge, summation of q. So what to write in the place of summation of q? Huh? So lambda is equal to charge by length. So charge is lambda into L. Is it lambda into L whole divided by epsilon naught? L cancel out. E is equals to lambda divided by 2 pi epsilon naught into R. Let us multiply it with 2 divided by 2. I will get 2 lambda divided by 2 to the 4 pi epsilon naught into R. Look, this one 1 over 4 pi epsilon naught is what is it? Is k now. So can I write it equals to E equals to 2k lambda by R? It is E net. This one is E net. Done. Let us do 1 to numerical, then we can just wrap up the today's session. So we have one rod with plus lambda density, one more rod with minus 2 lambda density. Both are infinite. Infinite. Distance between them is 2r. At central point, that is, it is r and r. Find electric field in net. Look, due to this one, it will be outwards, and E is equals to 2k lambda. It is lambda. Let us suppose it is lambda 1 and lambda 2. 2k lambda 1 divided by r. And due to this one, now it will be also this one. Okay, E2. 2k lambda, it would be 2 lambda 2 divided by r. It is 4k lambda 2 divided by r. So what will be E net? That E net equals to 2k lambda 1 by r plus 4k lambda 2 divided by r. This is E net. This is my E net. Done? And it is a NEET PYQ, right? NEET PYQ. Let's do one more numerical. How do it now? Look, one infinite length rod, infinite, plus lambda 1 plus lambda 2. Distance between them is r. Find force per unit length. Look, if I take a small element here, its length is dl and charge is dq. Due to this, my electric field will be outwards, and it is equal to 2k lambda 1 divided by r. Okay. So how to find my force? Force on 2 due to 1 equals to charge q2 and electric field due to 1. What is q2? It is lambda 2 into dl. E1 is 2k lambda 1 by r. So I can write 2k lambda 1 lambda 2 divided by r into dl equals to f. So look now. So I can write f divided by delta l is equals to 2k lambda 1 lambda 2 divided by r. This is my answer. This force per unit length. This one is my force per unit length. Done. Force per unit length. Okay. So we are done with today's class. Tomorrow we will discuss electric potential. We will discuss electric potential in tomorrow's class. Electric potential and potential difference or electrical potential energy. Okay. So these things we will discuss in tomorrow's class. For today, it is more than enough. If you have any confusion, you can let me know in 2 minutes. Okay. I guess we are done with today's class, and we had discussed it each and everything. We didn't miss a single sort of thing, right? Not a single thing. So we are done up to the Gauss's law, electrical field. Now from tomorrow we will discuss electric potential, and it will take a couple of days. Then our chapter is complete. Then we will start capacitance. The cone one. You didn't understand the cone one? Okay, look for now. Look. So if this is my cone, look. If this is my cone, this is my cone. Okay. So if this is the height of cone, h, and this is my radius of cone, r. Done, no? Electric field is coming in this way. We know that net electric field, net flux will be 0. We know that net flux is 0. We have to calculate incoming flux. First of all, incoming flux is always negative. We know this particular point. It is always negative, no? Okay. So look, for flux, what we need now? We need electric field, we need area. So in this case, which area we have to we need to take? Every time it is projection area, projection of area. And it should be maximum. It should be maximum. Look, if we cut it, if I will cut it from this particular portion, I guess this at this particular point now, look, at this particular point, my area will be maximum. Look, if we compare 1, 2, 3, 1, 2, 3, where the area will be maximum? Where from my electric field lines will pass maximum? From 1 to 3? Yes, sir. I guess 3 is very big. So maximum electric field lines will cross from third only, right? Yes, from third only. So we have to take area of this particular line. If we cut it now, just cut it from this particular end. What you will find? You will find a triangle like this. You will find a triangle like this. So what is area of this triangle? Look, height is given by h. Look, my radius is r. This is r. So this one is also r. So if it's my triangle with height is h, base is 2r. So what is area? 1 by 2 into base into height. It is how much? It is RH only. So what is my flux? Flux is minus ERH. Done. Done now. Okay. If you have any other confusion, you can just let me know. No? Because I think we are going with good pace, right? I guess before September we will complete our whole syllabus of 12. If we'll go in this particular pace, no, definitely we will cover everything before our time, right? Okay, if you have any other doubts regarding the class, you are in my Telegram. You can just ping me message there also. Okay. So if you want to find my Telegram link, you can go to the description part. You will get my Telegram, or you can go to the description part of my channel. You will get my Telegram there. So you can ping me message for there, now which topic you want to study and what kind of problems you are just getting in understanding any concept. Okay. So for today, it is more than enough. We had discussed so many things. The NEET PYQs, AIMS PYQs, IIT PYQ, JEE main PYQs. We had done all these things from basic. And if you want any other thing in this class, so I will wait for 2 minutes. If you have any other kind of doubts, you can ask me. If not, then we can just wrap the session. Thank you, Beta. Thank you. Bye. Good night. Thank you. Thank you, Beta. Thank you very much.